Alrighty, welcome everyone who is joining us for the webinar on stall catchers this time around. We're waiting on our guest for an extra moment or so, but you should be joining us shortly. And we'll just hang out here so that everyone can join in the meantime. Alrighty, thank you those of you who are joining us already. If you are our attendees listening, and go ahead and share in the chat, just introduce yourself with your name and where you're zooming in from. So in my case, hello, I'm Emma. I'm zooming in from Phoenix, Arizona, in the USA. We're fairly global. We always have at least one person from, well, at least one since Roland is not in the States. But we always have at least more than one, I guess, calling in from somewhere else. So we love to hear that. So if you want to share where you're calling in from, love to hear it. Hi, Trevor, over in Ohio. Nice. Excellent. Okay, well, while we are, oh, my screen sharing is paused. Are you able to see my screen, Roland?
No.
No? That's interesting. Okay, let me go ahead and reset that because maybe that's what's going on here. I love when Zoom updates right before you're ready.
We should be here in any moment.
Hi, Pietro. Okay, Roland, can you see my screen now?
Yeah, I can. Yeah.
You can. Okay, great. Okay. Oh, and awesome. Thanks for adding in your info here. Oh, just as a heads up, you can change your chat function to send it to everyone as opposed to just the hosts and panelists. I see Tom from Wisconsin. I see Shirley from Washington. Good to see you here in New York. Cool. Very cool. Awesome. Not that the other places aren't cool. I just want to specify. But good to have you all here. Excellent. Hi, Pietro. We're going to go ahead and get started, assuming my screen share is still working, and then we'll introduce you in a moment here. Okay, cool. Had a weird update on my Zoom the other day, so I'm glad it's not actually affecting it. Welcome everyone who's here to talk through or to listen about stall catchers. We're going to go ahead and get started with what we usually do. So just to give you a brief hello, my name is Emma Giles. I'm a program coordinator for SciStarter. I'm also an ASU student in a master's program, and I work with SciStarter and ASU to do a lot of things in the Phoenix and Arizona area for citizen science. Roland, do you want to go ahead and introduce yourself?
Yes, thank you. I'm Quality Assurance Coordinator with SciStarter, and I'm working from Lebanon in the Middle East remotely.
Awesome. Yeah. If you have any need to have any technical assistance, you can send that on to Roland as well, and he will be your IT support. So go ahead and use the chat for that as well. And speaking of the chat and the Q&A functions, both of those are available. So if you have questions about stall catchers, about citizen science as a whole, about SciStarter, you can put those in the Q&A. You can also send us quick chats. If it is a question that we prefer it to be in the Q&A so we can answer them all and keep track of all those, it helps us out a bit. But go ahead, if you haven't already said hello, you can go ahead and use the chat function to test that out for us as we move forward. Cool. Pietro, would you like to introduce yourself?
Sure. Can you hear me okay? Yeah. So my name's Pietro, as Emma said, and I'm director at the Human Computation Institute. And basically what we do is we try to come up with new artificial intelligence techniques that are kind of unusual, because instead of just relying on machines to solve problems, we try to take the unique ways that machines think and the unique ways that humans think and combine those things together to solve problems that cannot be solved in other ways. And so one way that this kind of approach comes into play is in some citizen science projects. So I'll tell you a bit more about how that special kind of blending of human and machine intelligence works in the project we're going to talk about today. So yeah, did you have a few more things to say?
Yeah, sorry,
Okay.
thank you for that. Yeah, we'll be talking about stall catchers and then anything else you think is pertinent in that regard too. I'd love to hear any updates on that. We will go through a couple slides just to give everyone a chance to get comfortable with understanding the uses of SciStarter, and then we will switch to the project. But just to get a baseline, we'd love to hear if everyone in here has done a citizen science project before or has not. Roland just put out the poll for you to answer. As panelists, I believe we can answer too, although I'm a host, so I can't sway the score. It looks like most of us are yeses. Okay, awesome. Yeah. All right. That's great. Okay, so 80% of the respondents are a yes, so that's awesome. The one of you who has not done that before, I'm excited for you for today. We will get you set up so you'll be able to do any citizen science project you set your mind to. And then also we'd like to know, sorry, I skipped one. Have you ever been to a SciStarter live event before? So these events, I do recognize some names, so I won't be surprised if most of them are yeses. Excellent. Oh, pretty split. Awesome. Yeah. Thank you all of you for participating. Yeah. Okay. So the majority of us have, but for those of you who haven't, we're super happy to have you here and hopefully we'll see you every time. I'm wondering too, some of us might be out today and watching the recording later because of the soccer match that I just realized is at the exact same time. So if you're interested in watching, what is it? Croatia and, oh gosh, Croatia against Morocco? No. Argentina, maybe? Ooh, I don't remember. I'll be watching it after. So we want to know what type of people you are. Probably not soccer watchers or football, depending on where you're from. Aspiring citizen scientists, we've got 50% of us calling that. Thank you. It is Argentina versus Croatia. Thanks, Trevor. And then researchers, project leaders, board person on the internet. So happy to have you here. Love it. Excellent. Okay, great. We're glad to have you all here and not watching the soccer game. We'll watch after. Excellent. Okay, so just to give you a good basic understanding, citizen science is all about being able to impact science and not just do science projects for fun, but rather be able to do it for fun and to actually contribute knowledge. So it's a collaboration. It's a collaboration between scientists and those of us who are curious, concerned, motivated to make an actual difference. And so these are really impactful projects. And one way, the first step to get involved in citizen science is simply to go onto SciStarter.org, set up an account, and look through all the projects that are available. There's more than 1,600 projects on there, and they're tagged by the type of project and the theme or the topic. And so you can find projects for all kinds of things. Today we'll be talking about medical research. There are projects about biodiversity and all kinds of space ones, etc. And so just using the SciStarter.org finder, the project finder, will get you all those different options. In addition to having that project finder and having an account where you can hold on to all those projects and mark them as ones that you've done and keep them in your sites as going back to them and continue working on them. We also have training for you. So if you are looking for a little bit more confidence in being able to do citizen science, we have the Foundations of Citizen Science training, which is incredibly useful and it forces you to do a couple of projects as practice in order to actually participate, which one of them is actually stall catchers. And so if you do the foundations training, you're actually going to run into the project that we talk about today, which is pretty great. Beyond the foundations training, we do have more specific trainings moving on. Data literacy is my favorite because I wish I'd used it when I was a 5th grade teacher for my students because data literacy is so important. We have one for libraries, one for higher education educators, and data ethics for practitioners as well. So you can continue on to more. Alrighty. I'm gonna get rid of the polls really fast. I'm gonna drop my screen so that Pietro is, I assume that's what you would like to do, to take over the screen, or do you want me to run it?
Sure, I'll go ahead and share screen then if that's
Awesome.
okay.
Yeah, not a worry. Go ahead.
Okay.
Hopefully it lets you. Let me know if there's an issue.
All right, bear with me for a second here.
No worries. Oh, one thing to mention before you actually share screen, if there's an issue, I'm going to share one more time, is that Stall Catchers, what we'll be talking about today, is also an affiliate that you can get set up pretty quickly. So if you go on to SciStarter and look up Stall Catchers, it's this link that will also be dropped into the chat. You can go to this one to be sent to stall catchers. And as long as you sign up with the same email as your account through SciStarter, it will track your contributions. So every time I check, I end up having most of my contributions through stall catchers. And it's because it tracks every time I go on to actually contribute my time. And so it's a really powerful tool to be able to do that. I'm not positive if you're able to see my screen because it looks like it's paused for some reason, but
Yeah, we
okay.
can.
Oh, well, we can send those links anyway, the one for SciStarter specific, and it will send you, all the instructions are there too. So not difficult to follow.
Okay, shall we
Yes, go ahead.
take a look? All right. Okay, so so yeah, basically stall catchers is a citizen science game that speeds up Alzheimer's disease research at Cornell University. And so I'm just going to give you a bit of background on the project, and then maybe at the end, if it makes sense, and people want to, try to register during this session, we could kind of walk through that process. Does that work, Emma?
Yeah.
Okay,
absolutely.
Great. As many people know, I mean, Alzheimer's disease, it's a neurodegenerative disease that tends to affect people in later stages of life and causes different sort of cognitive symptoms like memory loss is the one that I think is most closely associated with it, but it also can affect thinking in general and also cause depression and have other kind of impacts. So it's not a nice disease, and we'd like to see it go away, or we'd like to figure out a way to maybe delay the onset of symptoms for people who do have Alzheimer's. And if you delay the onset of symptoms long enough, then you effectively have a cure. So I was introduced to Chris Schaefer and Nozomi Nishimura at the biomedical engineering department at Cornell University about 7 years ago now, maybe 8. And at the time, I was interested in applying these methods I was describing earlier that we call human computation, which is the sub-area of AI where we're trying to get machines and humans to work together to solve problems. And a mutual colleague actually introduced me because she thought that Chris and Nozomi might have a need to apply these methods to their own Alzheimer's research. So when I met with Chris, he explained that there's an aspect of Alzheimer's disease that's been known since we first learned about the disease, which is that in human patients, there tends to be about 30% less brain blood flow. But it hasn't ever really been clearly understood how this happens, why there's this reduced brain blood flow. And just to give you an idea of what that kind of feels like, if you've ever been lying down for a while, like on the couch, watching TV or something, and then you suddenly stand up and you feel lightheaded, that's like a 30% reduction in brain blood flow. But imagine having that all the time. So that's what it's like for some Alzheimer's patients, for many Alzheimer's patients, because the blood is, of course, what transports oxygen to the different parts of the body. And so with less blood flow, you have less oxygen getting to the brain cells and feeding the brain cells. So they were interested in, again, trying to figure out what's causing this reduction in brain blood flow. So they did studies using mouse models of Alzheimer's. They had mice that had the human gene for Alzheimer's disease and manifest all the symptoms of Alzheimer's. Not just the cognitive symptoms, but eventually the kind of plaques and things that are seen in the brains of human Alzheimer's patients. So they manifest the full dimension of Alzheimer's disease. But the advantage of studying Alzheimer's in mice, among other things, is that a mouse has a relatively short lifespan. So you could, with a mouse, once they're, I don't even know exactly how old, but once they're 1 or 2 years old, they're getting old. And if they're going to have Alzheimer's disease, they start to manifest the symptoms. So they did these studies where they would look into the brains of these mice, while they're alive. They would do it in a safe way, and actually look at the tiniest blood vessels in the mouse brains called capillaries to see whether blood was flowing or stuck in these capillaries, wondering if this was the basis for the overall brain blood flow reduction. And what they found when they compared the wild type mice, the healthy mice with the Alzheimer's mice, is that the wild mice had only 0.5% of their capillaries that were stuck, whereas the Alzheimer's mice had 2% stuck. And that might not sound like a big difference, but when they looked at the downstream effects of those 2% stalled capillaries in the Alzheimer's mice, they observed an overall reduction of 30% in brain blood flow, which is exactly what had been observed in the human patients. So that gave them a basis in confidence for this capillary stalling to be, related to the overall brain blood flow situation. So then an interesting thing happened. They had a new student, a college student, working in their lab, and they asked her to run an experiment on the mice related to this capillary stalling. And they said, we want to try to light up the brains of these mice a little more for our imaging technology. So we want you to inject this drug into the mice that'll make it easier to see everything that's happening in their brains. So she gave the mice this drug, and then she compared the two groups again. And what she saw was that there was actually no difference between the healthy mice and the Alzheimer's mice in terms of the number of capillaries that were stalled. It was as though the Alzheimer's mice were somehow magically cured of this stalling. And she was afraid that she'd actually made a mistake and done something wrong in the experiment. So she was kind of, reluctant to go. But she went to Chris and Nozomi, explained that, I thought I did everything exactly right, but I don't see the stalling effect anymore. And so they kind of traced through what she had done. Everything looked good. And then they thought about it and they realized that the drug they gave the mice to light up the mouse brains for the imaging actually had an unintended side effect of making these stalls go away. It was an immunosuppressant drug. So it was basically demonstrating that there was some kind of immunologic response, like brain inflammation, that was causing the stalling. And when they gave the mice these drugs, that went away and the stalls went away and the brain blood flow was restored. And so they did this again intentionally a second time just to make sure. And this time they looked at the cognitive symptoms of the Alzheimer's mice, and they saw that these mice were getting their memories back and that the cognitive symptoms were going away when they gave them this drug. The problem was that this drug, as an immunosuppressant, completely removes the mice's ability to fight off infections. So it wouldn't be a sustainable treatment. In other words, if they kept giving them this drug, then eventually they would die from an infection, which means it wouldn't work for mice and it certainly wouldn't work for humans either. So the goal became to come up with some kind of drug treatment that could make the stalls go away, but didn't have these deleterious side effects, such as eroding the immune system. So I said, well, this sounds really promising. And then Chris said, yeah, but here's the catch. When we run these experiments, it takes us about a week to collect the data on these mice, but then to go in and look at all the different capillaries and try to figure out whether there's blood flowing or stalled in these capillaries takes us 6 months to a year just for 1 week's worth of data collection. He said at this rate, it would take us 20 to 30 years to potentially arrive at some kind of a treatment based on this approach. So then, it became clear that the goal was to speed up this part of the analysis, the part of the analysis where the researchers in the lab would go in and look at each little tiny blood vessel in the brain and then try to see whether blood was flowing through it or not. So, so our idea was to use these kinds of human computation methods to isolate each capillary. So we use actually a machine-based machine learning algorithm to figure out where the blood vessel segments are, draw an outline around them, and then that shows a human observer, this is the capillary we're looking at. and then put it in a kind of gamified interface and allow people to kind of move backward and forward in time to see whether or not blood is flowing through these capillaries. And that's how we basically created stall catchers, was to develop this interface and make it possible for anybody to look at these capillaries and try to see if they're flowing or stalled. And then with enough people working on it all at the same time, then we could take what would normally take 6 months to a year for a handful of laboratory technicians would now take a much shorter period of time. So today we have over 48,000 registered stall catchers volunteers. On any given day, we have 50 to 100 different catchers playing stall catchers. And consequently, we're accomplishing the data analysis 5 times faster than they used to in the lab, which means that we're answering these research questions every 1 to 2 months instead of every 6 to 12 months. You know, part of you know, how people, you know, come to be engaged in stall catchers and continue to be interested in it is we occasionally run these catch-a-thon events. So usually we do the international one in April during Citizen Science Month. And this is just to show you like how broad the participation is around the world. The very first time we ran one of these, we had participation in all 6 inhabited continents. And we almost had Antarctica, actually, but that didn't work out because they have internet bandwidth issues there. They depend on it for survival, actually. So they're like, no, sorry, we can't give up bandwidth for this. We want to live, understandably. And it's really amazing to participate because we do kind of a live Zoom session like this one at the beginning and at the end of these catch-a-thons, where you can see people all over the world, and we like check in with different teams and groups from different countries. And it's very lively, and everyone kind of feels like they're part of something that's really huge. Like it's people from all over the world who all care about, you know, finding a treatment for Alzheimer's disease that doesn't recognize, you know, ideological differences or geographical differences. We're all members of the human species working toward a single goal. And it's really kind of a unifying experience. So getting back to this kind of human computation stuff I was talking about, we use what we call wisdom of crowd methods to combine answers from many different people about the same blood vessel. So what this means is that, so some people actually get stressed doing this activity because they think, if I give a wrong answer, I'm going to mess up the research and they're going to come up with a wrong treatment for Alzheimer's. So that's not possible. We've kind of made it impossible for that to happen. Because if you give a wrong answer, which everybody gives wrong answers, I'm actually not very good at this game myself, but I do play it regularly. And I'd say like, maybe about a quarter of the time I get one wrong. And that's okay, because when I get it wrong, there are other people who are getting it right. And there are enough other people getting it right that when you combine all the answers together, you get something which is on the average right. In fact, better than on the average. Like we've sort of honed our methods so that it's right 99% of the time. So when we first started the Stall Catchers project, we came up with kind of a simple method of combining answers from different people, which was just to average them together. And we said, okay, well, what if we ask 5 different people? You know, what level of accuracy are we going to get? And then we measured it. Okay, what if we asked 10 people? Now what level of accuracy? So the more people we asked and the more answers we combined, you can see our accuracy measured in 2 different ways was gradually going up. And finally, once we got past 15 people, then we were hitting the numbers that we needed to be at least as accurate as the people in the lab who used to do this analysis. Fortunately, because that doesn't seem very efficient, we improved our methods over time. And so today, it actually, here it says 7, but it actually on average is about 4.5 people who are needed to answer about any given blood vessel. And then we can still achieve these very high sensitivity and specificity levels, which are, you know, measures of accuracy. So like where an average person playing stall catchers might get them 70% right, a lab expert would tend to get them 90% right. That's why they had 2 or 3 different lab experts, because then what they would do is if there was any disagreement among them, then they would sit down and look at them together until they could agree on what the correct answer is. But what we've done with our wisdom of crowd methods is we came up with a way to combine many 70% answers and consistently achieve this 99% accuracy. So we actually had a situation where the crowd answers were a bit different than the expert answers when we were trying to validate this. And so we went in and we looked at it, and eventually the expert said, okay, we agree with the crowd. The crowd was actually right on all these. So then we thought, okay, I think this is going to work. So how has stall catchers been used? So again, we're still trying to figure out, the impacts of capillary stalling on brain blood flow, and in particular, what's causing the capillary flowing and how we can disrupt those stalls. So there have been a number of research questions asked, and the results have been published in top-tier scientific journals that describe the role of stall catchers and stall catchers participants in analyzing the data. So this has actually become an accepted way to analyze data. And at the beginning of the project, it was actually hard to get support for this project because a lot of scientists were skeptical about how could you possibly trust members of the general public to analyze scientific data when they're not experts, and how could we trust them to give the right answer? And of course, our approach is we don't trust anybody to give the right answer. We trust the crowd wisdom to give the right answer. And you might notice that in these articles, one of the co-authors is listed as stall catchers contributors. And so we've spoken with the journals and gotten them to agree to include and acknowledge the contributions of stall catchers volunteers. And if you go to these journal websites and click on this, it's a hyperlink, and then it lists the usernames of all the catchers who contributed to answering that specific research question. So, by participating in stall catchers today, there's a chance and a pretty good chance that you could end up being credited in a journal paper reporting on Alzheimer's research that's hopefully leading to a cure. So each data set that goes into stall catchers is toward answering a very specific question. And most of the questions that we're asking are related to filling out this messy diagram here, which is basically a molecular model of the mechanisms that underlie the stalling phenomenon. So where you see these green check marks, that's a data set that was answered in stall catchers, that was analyzed in stall catchers and provided a research answer. So that's kind of filling out our understanding of these mechanisms. And then these question marks, those represent data sets that have yet to be analyzed by stall catchers that will help us fill out some other areas of this model. Once we have the whole model filled out, then we have a much better basis for understanding what kinds of drug approaches or drug treatments could be used either to prevent stalls from forming in the first place or making stalls go away. And actually, some of the latest data sets in stall catchers are looking at what are known as FDA drug analogs, meaning that they're drugs that are already approved by the FDA for a different disease, but they're being tested in the mice to make the stalls go away. And what's really exciting about this is that if they do have this property of making the stalls go away, they've already been deemed safe by the FDA for other diseases. So the pathway to getting them approved as an Alzheimer's treatment would be much shorter and much quicker. So I think that's probably what I have to say about the history of the project and its impacts. And then what would you like to do next, Emma? Would you like to walk through a registration process or something else?
Sorry, I couldn't find my unmute button. Thank you so much. That was so much excellent information. I actually did not realize that that's what that diagram was. So thank you so much for explaining that. That's really powerful to be able to see all those check marks of like the map of what is still unknown. That's really cool. I have a question in the Q&A before we move forward with any demonstration, but they're asking about, Trevor, thank you for asking, is there any potential for this type of interface for other diseases? And I remember you talking about it coming from a different citizen science project. So I was hoping you could talk a little bit about what you see in that in that realm of things. Oh, you might be muted. Yeah, you're muted again. Sorry.
Thanks. Yeah. Yeah, so I love that question, and I think, yeah, you're remembering exactly right, Emma, that that we got the model for the virtual microscope in stall catchers from another project that's not about biomedical research, but it's a NASA mission project called Stardust at Home. So that's another story. And I can provide a link if anybody wants to read up on the history of that. It's kind of a really sort of serendipitous and magical connection between those two projects. Just to more directly answer the question, we do see opportunities to use this interface for other disease research in this platform. When we began the project, we had other researchers studying, for example, arterial malformation, so malformed blood vessels, and there's another vascular disease that uses the same kind of analysis, looking at the blood vessels and the blood flow through the tiny capillaries. We're also adapting the interface right now to two other projects. One that is also studying Alzheimer's dementia, but from a different angle. It's actually looking at slides of slices of brain tissue from Alzheimer's decedents. So patients who died from Alzheimer's disease, donated their brains to science, and so there are these slides that have been digitized, and what we need to do is quantify the amount of amyloid plaque and tau tangles and the different types on these slides. So we're building an interface that will allow citizen scientists to contribute to that. And we're also looking at cerebral small vessel disease, which is also a different kind of dementia. And then that's going to be looking more at the tortuosity of the vessels. That is, we're going to show different vessels. We're going to ask people to trace the outlines of or trace the shapes of the vessels, and then tell us how twisty they are. Are they straight, or are they really kind of twisty? And that's going to help advance that research. That's looking at MRI images. So yes, we're gonna kind of expand the catcher space from just stall catchers to beta catchers and tau catchers and sickle catchers. So we've got a lot of cool things planned, and we're working hard on those. So yeah, great question. Thank you.
That's awesome. Do you have any idea when that first version of any of those will be available to your average citizen scientist? Is it in the foreseeable future?
Yeah, definitely. So I think probably the nearest term one is going to be beta catchers, which is trying to quantify the amyloid plaques on these slides. And we're actually, in 2 days, we're starting focus groups on our prototype interface of that. And we're going to just move that forward as fast as we can. We'll probably get some early testing. So if there are folks already doing stall catchers, we'll probably send out an email to anyone who's registered on stall catchers and see if anyone wants to participate in kind of like an initial try, like alpha testing or beta testing of beta catchers. Exactly. Well done. Yeah. So hopefully very soon. Yep.
Awesome.
Any other questions?
I didn't see any in the Q&A, but if there are any questions, feel free to drop them in. We can pause to answer any of them as time moves on. But I would love to demonstrate how to get logged on and set up. So sure. I'm going to go ahead and just replicate what I usually do with our corporate volunteers that really enjoy stall catchers. They use it all the time. You've talked to them before. So for anyone who wants to follow along, and I'll have Roland, if you wouldn't mind just duplicating what I add in the chat here to the Facebook chat, that would be super helpful. But the first thing you do in order to get set up, especially to receive contribution data, is to go through SciStarter to get to stall catchers. So the link I just dropped in the chat is specific to SciStarter. So I'll go ahead and head over there myself. And I'm going to attempt to share my screen again. This time I'll watch a moment to see how it goes. Hopefully it'll no issue. I'm going to send it to Google Chrome. Okay. It says paused on my end, so that's not That's not what I want to see. Let's see, okay, I'll stop it again. Let's try a different one. Okay. Do you
Not
see?
yet.
Is it working?
Yes,
Not yet?
we can.
It's working now. Okay, cool. All right, good to know. So it needs to go to the desktop. So the first thing I do is when I get to the StalkCatcher site, I would go to visit. And once you hit visit, it'll send you straight here. Now, I'm already logged in. I'm actually logged into one called SciStarter Live that I'm going to drop a link in here as well for you all. But we have a special team for today. So if you join in as a SciStarter Live webinar attendee, you can join this team to just show what contributions that this webinar helped make happen. It'll help us figure out how much effort is going into other projects after this. But essentially, it'll send you to the page to log in. So I'm going to show you that page as well, which I think you can still see my screen. I'm going to skip to get to it. So if I were to go to log out and it sends me here, I would hit join now or log in. So depending on if you have an account already or you don't have an account, you can click on those. By hitting join now, all it asks for is a username, and this one is public. So you write whatever you'd like, public facing, and then your email address must be the one you have with SciStarter. So assuming you have an account with SciStarter, this email address should be the same because that's how we tie the two together and are able to tell you your contributions over time. So on mine, I would log in using my handy dandy, oh, I'm already logged in though, so I need to log in here. And I would log in using this fake email I'm adding. I have a lot of StalkCatcher's accounts to make sure it works. I didn't have a password yet, so let's see if it's actually logged in. Yeah, it stayed in, so I'm good. So once you're on here, I'm gonna go and hit skip tour again, but I'm in this team, so the post I just added with the 772 at the end, that one is the team. So if you wanna join in that one, that'll allow you to be on that team. And then, oh, Pietro, thank you. Oh, awesome. Yes, if anyone was interested in the Stardust project, by the way, I'll add that to the follow-up email so you can look at that later as well. So once you're up here, you can go through the tour. If I hit replay tour, I can go through it. I'm gonna go ahead and make this giant screen. Oh man, it's making me log in. I'm gonna stop my share so I can figure that out really fast. But once you're in, the tour will give you the information you need in order to start contributing. So when I join in, log in, shouldn't have signed out. Oh well, that's okay. There we go. So once you're logged in, I'm going to go ahead and show you my screen one more time. Which will let me do that somehow. There you go. Okay, so I have got a couple of things going on. So I am going to join the SciStarter Live team. So I'm going to skip tour briefly just to say yes. Yes, I'm going to do that. And then the how to replay tour, it'll actually go through everything. So for anyone who is thinking, okay, yes, it may not matter about like you're one of the crowd, and so don't worry about messing anything up. They still do give you a tour of how to make this work or how to go through and do the project correctly. And so if you're still concerned about that, they go through all the different tools and tips of how to acknowledge these. Now, my account is fairly far along, and so these are not the training videos that you're looking at. These are where they get a little bit tougher. But as we go through the tour, it'll tell you how to look at all these things. So I often use this lovely thing to just move back and forth in the scroller because it gets a little bit tougher when they are smaller in the corner like this one, and explains what you're looking for. So we're looking at the white lines that come in and out of view are the blood vessels, and then in those blood vessels, looking at what is happening in each vessel as far as stalled versus flowing goes. So that's the main idea here, right? Pietro, I don't know if it'd be best if you are the one to explain what I'm like moving through. It might be easier.
I think you're doing a great job. I mean, I'm happy to chime in. I wonder if you hit the pause button, will that let you move that without it moving on its own? Yeah.
Yes.
Yeah, exactly. I think that's a nice way, because then you can sort of pause right where you see a black spot. So really what you're looking for is, in some cases, you have black spots that are moving through the vessel. And that's like, if you point, I don't know if you can point up to that one kind of closer to the middle that has lots of dots in it there. And you can see all those little tiny dots. outside of the outline. Like there's another like little
Oh.
capillary on the screen that has a bunch of dots that are moving along as you sort of move that
like
back
up here?
and forth. Yeah, even that one, I think. Yeah, let's see what that looks like when you move the slider. Yeah, so you can see the dots are moved. Well, actually, that one looks stalled too. Yeah, and it's interesting. Sometimes you'll see that, stalled vessels tend to go near each other because they're feeding into each other. So if one is stalled, then it kind of prevents flow in the one that's connected to it. But yeah, I think if you stop the thing right there, you can see there's kind of that black spot on the lower part of the outline. Yeah, right there. And so if you have a dark spot that just isn't moving through the vessel, no matter where you move the slider, that it stays dark the whole time, then that would be considered flowing. That's actually a tough one because it does at one point kind of cover up, doesn't it? What do
It
you
looks
think
like
that
there
is?
it could be stalled, but then when you keep moving, like
Then
right here, everything
Yeah.
is full.
Yeah. So I
Yeah.
guess, maybe flowing is the right answer there. Give it a
Shall
try.
I test it and find out? Yeah. And then we go, yep, correct.
Hey,
Ooh,
you're
400
right. Yeah.
points too. Nice. I remember getting like the 15 points from doing the trainings and
Right.
whatnot. I'm like, oh, cool, 15. Now I'm just 400. This is the best.
Yeah. No, that's a lot of points. And basically the amount of points you get for getting a right answer goes up as that blue bar gets higher. So the higher your blue bar is, that's your sensitivity, like your demonstrated ability to tell the difference between flowing and stalled. So you get more points the more consistently you're getting them right.
Do you have any idea? I don't know if I want to know the answer to know if I'm bad at this or good at this, but do you know the average level of the blue bar is
That's
for
a
a
good
general?
question. I don't. I think what we're looking at there looks above average to me, from what I've
Really?
seen. Yeah, I think so. Yeah, it's hard to be consistent, and it's the kind of thing where it takes a long time to build it up, but it only takes getting a few of them wrong to knock it back down, and then you have to work a while to build it back up again. Sometimes I call it a trust bar because, trust is hard to win, but then it's easy to, knock it down. So.
Oh, that's a good way to think about it though. Yeah, the trust bar. That's good to know. I keep telling people, yeah, my sensitivity must be like very poor if it's not even halfway up there, but that makes me feel better. Thank you for that. Amazing. Roland is asking a question about the points by simply answering. Oh, this is a good question. So the points are earned when we have the answer. So when I look at the top here, 100% data set verified, does that mean I'm looking at ones that have all actually been answered then? So all of these have been marked as flowing or stalled?
So you'll still get some of the research ones. So we have a crowd answer that we sort of trust for those, but until we get new data from the lab, we'll continue to collect answers from people, which will then further reinforce. And also it gives us an opportunity to test our crowd methods because we still go back. So there are like two kinds of research happening here. There's the Alzheimer's research, but then there's our AI research where we're always trying to make our methods more efficient and better. We want to be able to come up with really good answers using less time and like fewer people looking at the same vessel. Because we basically have this kind of, motto of first use no humans. And like we wouldn't want to waste anyone's time. So we're always, so we take data like this where we already have a fully analyzed data set and we keep gathering data and then we use that to improve our methods.
That's excellent. I always wondered about that. I'm thinking it because I've been in here when there's not 100% data set verified. And to answer Roland's question about getting points when you don't have the answer, from my knowledge, when you do answer flowing or stalled for one that has not been certified by a researcher, it gives you like a credit of like, we're probably like check back later to get those points. And that's where you would do it here. Oh, actually.
Exactly. Try it. Yeah.
Oh, yes.
Yeah. So what happened here, that's awesome. So basically there were 7 of those kind of maybe ones that you answered. And it turns out that all 7 of your answers agreed with the final crowd answers. So now you're getting all the points that were due to you.
Okay, I feel very cool. I just want to clarify for everyone listening, I do this as a training exercise with people in a corporation that mostly answer for me. And so I already have a crowd there telling me the answer. So technically I am cheating the system, but we will keep that between us and YouTube and Facebook and everyone who will see this. So that's
okay.
awesome.
Still helps the research either way. So, you know,
and then all
win-win.
the people who were doing that, they were signing up to do this in real time. So we were doing it together too. But that's excellent. I'm super excited about that. So you get your points later or at the same time, depending on what the data is that you're looking at. Great. Anybody want to help me out with this one, actually, just so I can repeat my cheating nature of this game? Feel free to let me know what you think. I'm going to go ahead and run it fully and see what we can see. Oh gosh, it's so tiny. So I'm looking specifically for little black dots, right, to see if anything is blocked. And if there is something that's consistently like blocked, then that's when we know it's stalled. But right now I'm not seeing anything that's actually actively stalled unless anyone can point at something. For anyone who's on.
That's an interesting one too, because as you move the slider to the right, you're going forward in time, but you're also going deeper through layers of brain tissue. And not all of the vessels are cooperative and are lined up horizontally. Some of them actually go down through the brain tissue, kind of like this. So that bright white dot that kind of, you know, stays in one place, that looks to me like, you know, a blood vessel that's oriented more vertically. And so as you move the slider, you're actually going down through cross sections of that vessel.
Oh, wow.
So these are nuances that, you know, people don't learn right away, and you don't need to learn them right away. But over time, as you become a more skilled player and you want to try to get that bar even higher, then you start to ask on the chat, and like some of the more experienced players will explain these things to you. And we have it in the FAQ as well, I think.
Oh, that's right. I want to show the chat. Let's see. Let me zoom out a little bit. I'm going to go with flowing, just based on my own. Yay, okay. But if I were to go down here, expert answer is flowing. And then there's also community answers. Is this where you're saying like there could be conversations about what's going on?
Well, that's a great way to find out as well. And also, if you just notice that there are people online, there's a live chat that's built into the game, and you can ask questions there too. And right, that one. Yep. And
hello.
Yeah, people with stars next to their names, like Capraram, they're like community leaders, mentors, and they're like really, you know, nice about helping people out when they're getting started.
That's awesome. Love that. Yeah, it's a giant community. It really does kind of epitomize the whole idea of crowdsourcing really significantly impactful data on multiple different projects too. Looking at the AI, looking at the Alzheimer's research, it's pretty impressive to be able to be a part of all these different little projects and have the community that's been built up. It's incredible. When did Stallcatcher start? I don't remember if you mentioned that.
Yeah, I mean, I think that the earliest conversations were happening sometime in 2013 or 2014, but then we launched, the public launch was October of 2016. So that gives you an idea of how long it takes these things to come to fruition sometimes. And so it's been running for,
yeah, how many years is that? It's funny to be thinking like, that doesn't feel like that long ago, but it was.
Yeah, exactly. Yeah.
Like a decent
hard to believe.
time. I know. Well, we lost like 2 years, right? We can pretend we're 2 years younger than we actually are.
Didn't happen.
I'm seeing also in the chat from Trevor again, do you think this task could ever be done 100% by AI?
Great question. In fact, that's where we started. So when Chris was showing me the initial kind of analysis that they did in the lab, I asked him if they'd tried machine learning models to do it, because we wouldn't want to waste human time if machines could do it well enough. And he said they had, and the machines were about 85% accurate. But the problem is with machines, you can't, if you have, you know, if a machine gets one wrong and you have two machines that are identical, then if one machine gets it wrong, all the machines will get it wrong. So that's why wisdom of crowds works, because of the diversity of people. But what we did is we decided to take 4.5 years of stall catchers data generated by human catchers. And then we ran a machine learning competition to see if we could do better. And we ran it with an organization called Driven Data. And it was sponsored by MathWorks, who makes the MATLAB software. And there were 900 participants on like 70 different teams competing to come up with like the best stall catchers classifier, using machine learning. And the top 3 models at the end of the competition were performing at around 92 or 93%. So taking all the crowd generated data and then using that huge corpus to train the machine learners, resulted in a dramatic improvement, but still not good enough that the machine could completely replace stall catchers, which is, analyzing at a higher rate. But then we decided to do an experiment. We thought, what if we take one of these high performing machine learning models and let it play stall catchers as a member of the crowd and be part of the crowd. And then so we kind of came up with this concept of a hybrid crowd where you have some humans and some bots. And that research is ongoing right now, but our preliminary results are very positive. And it looks like when you have a hybrid crowd, it actually does better than humans alone and bots alone. So I think slowly the goal is to phase out humans, to be honest. We want stall catchers to be obsolete because we have these other disease research projects that we're doing, like the beta catchers and the new ones I'm mentioning. And so if we can get machines to do stall catchers, then it's like that can run on its own, and now we can focus our attention on the next disease. So we'll always have new need. We'll always have an ongoing need for citizen scientists, but we're going to try to use the data from the citizen scientists to help teach the machines to do a better job. So I love the question. Thank you.
That is awesome. This is all so fascinating because we're looking to the future of what it will look like, and that's, I don't know. Yeah. I'm very nerdy about that, so it sounds very cool.
Yeah, it's fun. It's really fun.
Yeah. All right, we are at 7 minutes out from the hour, so I'm going to go ahead and stop my share for a moment. For anyone who is joining us, hopefully we were able to get you situated on the site. I do see another question actually from Roland. Are new data sets always being added, or if it's not the case, does showing vessels to more participants improve the crowd's accuracy? So do we continue to improve accuracy even with the data set being 100%?
Yeah, so so the simple answer is yes, it continues to improve the accuracy. We don't always use that information to directly improve accuracy of the data set that's been analyzed, but we'll use the additional data to reevaluate our wisdom of crowd methods and see if there are ways to improve it. So sometimes, like for some of our more prolific players, by the time we get a new data set in there, they will have analyzed all the vessels in the data set such that they're seeing the same vessel a second time that they've already seen before. And it's really interesting in those cases to notice that people don't always answer the same way twice about the same vessel. And so it kind of raises the question of, like, if you had the same person answer 10 times, would that give you a better answer, than if they answered one time about the same vessel? So these are kinds of questions we like to explore.
Well, that is fascinating. I don't know.
Yeah.
I feel like a nerd, but in a good way. That is excellent. Thanks for asking that question, Roland. If there aren't any more questions, I'm going to go ahead and close this out. But if there are any questions or anything, you can always contact us, and we will share the questions to make sure that they get answered. Can I get a thumbs up about sharing my screen? Is it working? Okay, I don't know what this new update did, but it's been weird. Okay, all right. So just to close this out, thank you so much for joining us, Pietro. It's really great to have you back with us. Or I shouldn't say back with us, just because it was another thing that I worked with you on. But still, good to talk to you again about this.
Yeah, likewise. Yeah, thanks for inviting me. It's been a lot of fun, and I appreciate the great questions and engagement.
Also, to know, I don't even think I noticed or I said it at all, but it was stall catchers was the #1 on SciStarter for all of 2022. So that is a crazy achievement. So we're super happy. And that's why we did this. I apologize, I didn't even think about that. But that's
great.
It's super impressive. So we're excited to keep that momentum moving into 2023. So everyone who's listening in or listening in later after the soccer match, we want to continue that momentum, so keep it up. For next week on December 20th, one of our participants today, but one of our hosts will be chiming in as our host next week. Trevor will be joining us to tell us about how satellites track Santa and do science. We'll be talking to NORAD and also GLOBE for clouds, our Globe Observer clouds. And so we'll be learning about how satellites are involved and how citizen scientists are able to get involved in that research. And then we will be taking a mini holiday break, and we'll be back on January 3rd with Instant Wild, which is an online, if anyone is in an area that snows, there'll be a lot of online classifying, and it'll be super fun. If you ever need an update on what's going on, we have our blog that Roland will drop into the chat as well. We do have Citizen Science Month coming up in April. April of 2023 is the biggest push of the year to talk through or to do the most contributions in citizen science. There are a lot of events that will happen, and they're mostly, and we're trying to get all of them uploaded onto our SciStarter events tab. So if any events you know of are happening, or you're doing events in your own community, you can always add them to our scistarter.org/add-event, which we can add into the chat as well. And it's now in our follow-up email, so you can always revisit that later. But yeah, that's the biggest push. We work with libraries to make sure events can happen, and we really push for as many people as possible to get involved. Even if it's for one thing, it's still impactful. And then lastly, as we usually describe, we have all these resources for you that we want to make sure that you are aware of. Please ask us questions if you need any assistance or have any advice for ideas for events, or you want to tell us about what you would like for this specific project, the webinars. We are happy to hear that from the survey or an email, all that's good. But there's always resources of asking the community in the SciStarter project pages. We have a podcast. Bob Hirschon, who's been on for the SciStarter live webinars, does our podcast. And so you can always listen to him a little bit more on what those projects are when he has those interviews. And then there's trainings, new projects, the project finder, etc. You know the drill if you've been here a couple times. Yeah, so all these are available to you. We look forward to next week talking about NORAD and NASA. And we would love it if you could fill out that survey for us that I already mentioned. It'll help us a ton. And I do see some chats coming in, so I'm going to check that really fast in case it's not just the sites. Oh, of course I can't see it. Never mind. If there is anything I need to answer, Roland, let me know. There's anything else? Nope, we're good. Okay, awesome. Well, thank you everyone for joining us, and thank you so much, Pietro, for explaining all that. I learned so much. I thought I knew stall catchers, and this has been really helpful to really contextualize a lot of it. So thank you so much.
Yeah, no, thanks again. It was a pleasure. I'll see you next time.
All right, I'm going to go ahead and close out this this recording and the Facebook stream. Bye, Facebook. And goodbye, webinar.